This video is going to show you how to write ionic formula. Now this is the exact same method as we've learned previously when you are given a compound, so two words, and you have to work out the formula for it, and you would have to use the valency method, which we have done as the SVSDF method. So it's exactly the same as that. However, there's an extra rule involved where you must include brackets and ion charges for all of the elements involved. That's why we call it ionic formula, but it does look very similar to other chemical formula. So I've got 3 examples here. Slowly gets harder, but hopefully that will cover everything you need to know. So if you were asked to write the ionic formula of potassium oxide, symbol is K, oxygens is O. Now the difference now is we've said brackets and ion charge is always used. So this is going back to valency values, comparing them to ion charge. Now we did cover this when we looked at ions, and we pointed out that group number, everything in the same group has the same valency. So group 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 3, 6 is 2, 7 is 1 and 8 is 0. Now the link we're making this time is that ion charge is the exact same as valency. So valency equals charge. But we have a wee trend here because there's positive and negative charges. So the first 3 are positive, the last 3 are negative. The group 4 elements we don't really ever get asked about here. So we'll just ignore them for now. An easy tip to remember is that all metals are positive charges and all non-metals are negative. And that will match in with the trend. What a lot of people like to do is on page 6 of your data book, add in the charges along with the valencies, just so it's a quick way to check it. So if you use your data book correctly, potassium's ion charge, it's in group 1, so it has a 1+ charge. So we just write in plus. You can write 1+, but it's 1, so it doesn't matter. Oxygen's in group 6, which makes it valency 2, so 2 negative. Now you must put the 2 for that one. At this stage, we must put both in brackets. So they 2 parts there, the charge and the brackets, are the main difference between this and formula, in chemical formula. So valency, we've said, equals charge. So from here it's the same as what you've done. So valency is 1, charge is 1, oxygen 2 minus, so valency is 2. Swap them over. And our final answer, including the brackets, K plus with the 2 outside. So you rewrite your symbol and then just put the wee number outside those brackets. O2 minus. And you can put the 1, but we've learned previously that you don't need to put 1s. You can leave your final answer as that there, but again, as we've learned previously, you can remove brackets if there's no number outside. So you can't remove these ones, but you can remove this one. So that could become this here, but either would be accepted. You're more likely to see that one, but you can still get the mark for this one. So again, copper 2 chloride, copper Cu, use your data book to find that, chlorine Cl. Copper is a transition metal, it is not going to fall into one of these groups, so you're always given the valency as Roman numerals like you've learned previously. So the valency is 2, and to get the charge, the ion charge, we need to use this rule here. Metals are always positive. So the charge is 2 positive. Put it in brackets. Chlorine, group 7, so is 1 negative. And same as before, so valency is 2, chlorine's 1. Swap them. We become Cu2 plus. You don't need to put the 1. Cl minus 2. So it could be rewritten like this. You cannot, if you remove those brackets and there's a number outside, you're getting your answer wrong, even though you've done all that work, and it's only 1 mark. Aluminium sulfate, so a wee bit harder. Aluminium's Al. Sulfate, so 8 tells you it's page 8. Sulfide would be sulfur, but sulfate is SO4. Charge of aluminium, it is in group 5. Is it group 5? Sorry. Group 3. Aluminium's in group 3. So group 3, it gets a 3+ charge. And valence is 3. Remember your brackets. SO4, now this is where page 8 comes in handy. So check page 8 and you'll find sulfate there. You've used SO4, and before I told you to ignore the charge, but now you need it. So 2 negative is the charge. So that's the easier one because it's already written out for you. Brackets, valence is 2 because valence equals charge. Swap them over. These won't divide. So this one becomes Al 3+ 2 SO4 2 - 3. So essentially what's happening is in the final line you are taking what's ever in brackets and rewriting it. And whatever you get at as your valency, your final value in the divide section goes in there. And it's the exact same every time. Again, in that one, that's the only option. You cannot rewrite them without brackets because they have numbers outside. A quick way, now not everybody likes to do this, so you can ignore it. This would still get you the correct answer. A quick way to check you're doing it correctly, this is referenced in the PowerPoint. The overall charge should equal 0. So if you think about this, 2 times 3+ is 6+. 3 times 2 negative is 6 negative. If you do that, you should get the same number on both sides and they would cancel out. If it's the same number, then you have done it correctly. But you don't need to do that. That can just be a way to confirm you've done it correctly. But if you follow this method, then you should have done it correctly.